The board game Risk consists of 42 territories. At the start, each player places about 45 troops on the board. Then, the first player can attack any place that borders its territories with up to 3 troops, as long as there is at least one on the original territory. While the attacked player can defend with up to 2 troops if there is more than one on that territory. Then the first player, after he's done attacking as many times as he wants, can move their pieces anywhere as long as there is a path between that place and the original place that they're moving from that they own. Then the next player goes, and you repeat this until one person owns everything. It has gone down as one of the all-time classic board games. But it's also stupid. Like, why do I have to move all these pieces around the board, and suddenly there are even more pieces to move? And don't even get me started on the cavalry and artillery. What, it takes 10 troops to make one cannon? Yeah, that's definitely realistic. Jeez, if there was only a digital version where it did all these things for you. First, we need a PNG of the board. Okay, this will do. Then we'll need to set up our HTML, CSS, and JavaScript files. Now we need to find out how to make individual countries separate objects that are clickable and stuff. Okay, so I can use these things called scalable vector graphics. They're used for logos on websites because they make rudimentary images via code. Alright, let's make an SVG of Japan. Here we go. So I would like to give you all my personal information. Now just download it, open a browser, copy the SVG code to my project, and wait. Why isn't it in the right place? Okay, now to the rest.
3 days later.
Wow, that was super fun. Not monotonous at all. Now that we have the board, we should probably work on a little bit of UI. So let's have it so that you can click on one territory and then another territory, and those territories will be now connected by a line. So let's make a dot and add a document function so that when you hover over a territory, the dot's top and right position will snap to the territory you were hovering over. That is not remotely where it is. There, now it's doing the thing. For the second dot, I want to have it and the line follow the cursor. So I'll make a function that gets the X and Y position of the cursor and then applies that to the dot. For the line, I'll make an HTML element that's just off screen until this function is called, which will set its left and top to the first point. For the width, we'll just set it so that the distance between the 2 points, that's this formula, and that will make the line as wide as the distance between the 2 points. Okay? Now we just need to find the correct angle to turn the line in the direction of the second point. How do I do that? No, that doesn't work. Finally, we got something. Using math.a102, I can find the angle between the points using the difference. Just gotta apply this to CSS. That doesn't seem right. Let's multiply by 100. Divide by 2? Power of 2? What about, 180 divided by 3.14? Oh, that works. Nice. Then we just snap the end of the line to the second point if another place is clicked. Just add simple clear function to remove the 2 points and return the line to its original position off screen, and there we go. Now we have shitty Google Maps. For when people from northern Michigan want to go to 1331 47.5N 3723 16.7E for vacation and nowhere else. Okay, so we know what our territories are named, but in Risk, territories have an owner and the number of any given troops on it. JavaScript has a variable type called object that stores multiple types of variables under different names. Like if I made one called banana with its weight and height. Well, if I want to use its height, I'll just say banana.height, which will reference that value as if it was a normal value. We'll just make a variable for Japan add its HTML ID as its area, set its current owner and num troops to 0, and its bordering territories as an array. We'll get to that later. Now just repeat that for the rest of the 41 territories. Oh god. Cool. Okay, done with that. Now we need a way to find which object we're hovering over and pull up data from it. So let's try something like this. Maybe if I write out the areas and their associated objects in a different array. Nope, that was just a waste of time. Oh, I don't know. I know what to do. Okay, now when I hover over it, it logs the object associated with it. While we're at it, we should probably store the ID for the 2 points in their own separate variables. And the move function ID is good to go. Wait. Now it's good to... Why isn't the background showing up? Yeah, it's not breaking the program. I'll just fix it later. Now that we have the data for each territory, we can start adding the actual game part. Let's start with moving troops around. Add 2 buttons that control how many troops you're sending. Add a confirm button and the cancel button. Then make a function and use 2 loops to store the objects. In the function, I'm going to add that cap max as 1 minus the maximum amount of troops on that territory. Then just make it subtract t_num from the first object and adds to the second object. We can move. Now let's attack. First we'll need dice represented on HTML. This works. Shout out to this guy for the designs. Now, in Risk, the one attacking can attack with up to 3 dice, and the one defending can defend with 2 dice. To simulate this, let's add a screen for battles where there are 2 sides for attacking and defending. And let's add 1 dice to the left side. Oh, the div wasn't loaded in yet. We'll make a function and only use it in sectioned codes where we know everything is loaded in. Then we'll add a little thing on the bottom that will pick a random number from 1 to 6. That seems important, just a feeling. So now we have a function that places dice on the left and right of the screen that has a random value assigned to it. But the number isn't displayed on the dice. For that, we'll need to manipulate the grid. A grid in CSS is a property that, when applied, will shift the elements into, well, a grid. We can make a grid with 3 rows and 3 columns using this. Then by using grid template areas in this formation, we can match locations where dots on a die are and assign 6 dots to the letters. Now to manipulate the grid using JavaScript, we can probably try and change the grid area of the dots. No, that didn't work. GPT. What do you mean? Oh, they don't have to be visible. I forgot. So what we can do is just set up an if statement to determine whether the number of the row was even or odd. If it's odd, just move the 6 dots in the middle, else do nothing. Then we can write individual settings so that the opacity of each dot is set so that it can display the number. And okay, it matches. Neat. You know what? Let's make it so that it rolls 10 times before landing on the final number. Wait. Oh. Why is it? Come on. You know what? Screw it. We aren't having that. We'll just roll the dice once and be done with it. It's faster anyways. Now that we have the dice, we need to determine who wins. Well, how is that determined? Basically, the 2 highest numbers from each side are checked to see which is higher. If there are more higher numbers on the attacking side, then the attackers win. If there are higher numbers on the defender side, the defenders win. If there's an equal number of attacking and defending wins, then it's a tie. The potential third attacking dice probably saw how screwed he was and got the hell out of there. We'll create 2 lists and fill with the numbers that we can return from rolling the dice function to get the number of rolls from highest to lowest for each side. We can sort the list and reverse them to get the numbers from highest to lowest for each respective side. Then we make a bunch of if statements to determine the winner. The result of the two highest pairs, represented by true for defending win, false for an attacking win, and the string tie for A. Tie. It works. Just add a little UI to display the winner and then let them continue after that, and we're good with the attacking. So we built all these functions for battle, but you won't see it in game except for the start. We now need to incorporate the battle function into the rest of our code. So first I'll make a button that switches from you are now in move mode and you are now in attack mode when clicked. Then go over to this function and change the maximum troops you can put in. And in attack mode, we'll use the number of troops as the amount of red dice we use. Good, that's working. Now that the attacking is ready, there needs to be a way you can pick how many dice you want to defend with. Since there are only 2 options at any time, I think there should be a drop-down menu. How do I make those? Now that we have our drop-down menu, we'll just add a function to check the value of it and use that as the second input into our battle function. Now you can choose your attacking number and defending number. What do you mean B.num troops is undefined? Let's try. No. Okay, it's because B is being cleared before it reaches this function. Just make another thing that saves B and that's fixed. Now the battle system is fully implemented and... Wait, don't do that yet. I haven't decided to do it. What are you doing, Dear ChatGPT? When I run get option, it finishes running battle. How do I fix this? Okay, so I can fix it by telling it to wait for the battle using a promise. I'll just move everything before battle to battle, and now the battle system is fully implemented. Now what we should do is... Hey, you looking to do some programming? Yeah. Well, according to this new payment plan that just came up, you're about 1 year overdue on your free trial. Okay. Well, I guess I'm using VS Code now. Now, where was I? Got defend working, now the battle system is working. Wait, what are those? What? Okay, turns out this loop sucks at removing dice, so I just placed it with 5 lines that remove the dice individually. Now, where was I? Oh yeah. It's time to decide who owns the world, or at least the territories in the game. Let's start by making a function that highlights each territory in a different shade color when the number indicating ownership is 1 to 5. Make sure it's in RGB format, and there we know who has what. Right? Like, we just know who has what. Currently, though, it doesn't mean anything because I can click on any territory. So let's create a variable that cycles from 1 to 5. We'll call this turn order. And you can only click on territories when the turn number is equal to the owner of that territory, with the exception of when you're attacking and point num equals 1, or when this is happening. Okay. Yeah, that works now. We should put our attacking, moving, and turn order together. So I'll default the button that switches attack and move around so that attack is default. Then I add the button that switches, so now it activates a function that checks what mode you are in. If you are in attack mode, you switch to move, and if you are in move mode, you switch to attack. And the player turn increments by 1. Now we have a negative sum version of the game that goes on until you run out of troops. That kind of sounds like a good idea. But later though. Now that we're getting to the end, it's time to implement some smaller details. Like how at the beginning of your turn, you gain troops based on the number of territories you have. You then have to place the troops before you can move on with your turn. So I'll make a variable and make a function that checks if you own each territory and add 1 to R for each one that you do. Then in the end turn function, we will add a little thing to display your reserve visually. Then we need to force the player to place their reserve on the board before continuing. So I'll go back up here and ask if R is equal to 0. If it's not, then I'll just add 1 troop to this remove 1 troop from R. And hold up, it's not removing it. Why? What? Oh, there's no object in the reference. Current 1 pulls the owner from the object. Let's make another one to pull the number of troops. It's still not working. Current 2 is just a number. But how do I make it reference the object? Could just make it the object. Now you might ask, doesn't this make current 1 obsolete? And my answer to that is screw you, I'm not changing it. See, that works. Now all that's left to do is determine a winner once one player has all the territories. And the main menu where you can select the amount of players you want. And we're done. In Risk, you can only attack territories that border your own, and you can only move pieces to territories that are connected via some route in your territories. So I filled out the bore section of the objects. Here's me doing that. Please, oh God, make it stop. Okay, so the attacking part isn't actually very bad. I just have to check where the territory you're trying to attack is a border away. That was easy to implement. Now comes the hard one. Take a look at this. I want to move some troops from here to here. You would look to see, oh, I can move it because of these territories. However, there are many other paths to take, and they are all equally valid. Now I don't know how to tell a computer this. Well, Google Maps is basically the same thing, so let's check there. Google Maps uses image recognition and algorithms to extract useful information from the satellite and street view images used to create the map. These algorithms can recognize specific objects and real-life situations such as roads, buildings, lamps. Screw it! You can only interact with territories that are boring you. I can't do it. I give up. I'm done. And with that, it's done. This was a genuinely fun project to work on, and I hope you enjoyed it too. If you want to play it, there's a link in the description for an updated version with better menus and animations. Thanks for watching.